Hi everyone. Today let us discuss about baseband coding. Before going to discuss about the various kind of baseband coding, let us see what do you mean by baseband signal. So baseband signal is a signal which is transmitted without any kind of modulation. That is the original signal. So which may be analog or digital signal. In data communication, baseband refer to transmitting the digital signal directly over the medium before or without any modulation. So baseband coding is a process of converting binary data ones and zeros into electrical signal for transmission through the medium. Baseband protocols, which describe the rules and procedure for communication between devices. In baseband communication systems, a protocol governs how data is framed, transmitted, and controlled. Let us see the baseband data format. So this is a message frame which consists of four fields: preamble field, address field, data field, and parity bit. What is preamble field? Preamble field, it tells the receiver when the message begins. Then the address field. So this is identifying the this is used to identify the address. So that is unique to the transmitter, and its purpose is to notify the receiver from where or from which unit the message is coming. Then the next one is the data field, so which indicates the type of data is being transmitted as signal. The last one is the parity bit, which allows the transmit receiver to determine whether the message was received correctly or not. And before going to this one, so let us see what are the criteria for baseband for choosing a baseband code. So there are six criteria to choose the baseband coding. One is timing. So that is timing. The receiver must be able to recognize the transition between each bit. So the bit transition must be independent of message content. So that is, they must be identifiable even for long strings of ones and zeros. The next one is a DC content. So that is nothing but the average level of message, so which remains constant throughout the message frame irrespective of the content of the message. Then the next one is the power spectrum. So power spectrum is nothing but the baseband coding system have different frequency responses. A system with narrow frequency response can be filtered more effectively. Then inherent error detection. So codes that allow the receiver to recognize error on a bit by bit basis have a lower probability of getting a false alarm. Then the probability of error. Codes differ in their ability to properly decode a signal given a fixed transmission power. Then the polarity indifferences. So sometimes there is an advantage in using code that retain its characteristics and decoding capability when inverted. Baseband coding. So the commonly used baseband coding or line coding techniques are unipolar encoding, polar encoding, Manchester encoding, and bipolar encoding. So unipolar encoding. So unipolar, as the name suggests, it has only one kind of pulse. So it uses only one low voltage level. So here one is binary, one is represented by a pulse of some amplitude or A or some for example 5 volts. Binary 0 is represented by 0 volts, which means there is no pulse, absence of pulse. In polar encoding, so polar means it uses two pulse. One for positive, binary 1 is represented by positive pulse and binary 0 is represented by negative pulse. So different examples are NRZ and RZ. So in NRZ, non-return to 0, RZ return to 0. So non-return to 0 means there is the no pulse return to 0. So which maintain a constant level for entire bit duration. Return to 0 means signal each pulse returns to 0 between bits. What are the types of NRZ? So there are three types of NRZ: NRZL, NRZI, and NRZM. In NRZL, there is NRZ non-return to 0 level. So it does not return to 0 during the entire bit duration. So here the binary bit 1 is represented by a positive pulse and 0 is represented by negative pulse. NRZI, non-return to 0 inverted. Binary 1, there is a change in the signal level at the beginning of bit, And for binary 0, there is no transition, there is no change in signal level. It remains the same. NRZM, non-return to mark, this is similar to NRZI but follows some different convention. Binary 1 mark, so there is a transition. Binary 0 space, there is no transition. And third type of coding is Manchester encoding. So here there is a change bit has a each bit has a transition. There is a transition in the middle of each bit for good synchronization. And the last one is bipolar encoding. So alternate positive and negative pulses are used for binary 1 and 0 is represented by no pulse. One example is AMI, alternate mark inversion. Let us see how to represent the given data using NRZ, that is non-return to zero. So non-return to zero is the most familiar code since it is used in digital circuitry, serial wired, short distance communication links like RS-232. However, it is rarely used directly for wireless communication. So here binary 1 is represented by positive pulse and 0 is represented by absence of pulse, and there is no inherent error detection. If NRZ coding is used, then error correction or reduction field is imperative. Let us take one example. 10 is the given data, 10110001. How ones and zeros are represented in NRZ. So 1 is represented by positive pulse. So this is represented by a positive pulse, and 0 absence of pulse or no pulse. Again 1 is represented by positive pulse or pulse of some amplitude. Again positive pulse 1, then 0 no pulse, absence of pulse or no pulse, then 1 again positive pulse. So this is how ones and zeros are represented in NRZ coding. Then the next one is bipolar Manchester code. The primary advantage of Manchester code is it's a relatively low probability of error compared to other codes. In Manchester coding techniques, so there is a bit transition in the middle. So every bit has a transition in the middle. Binary 1 is represented by a positive pulse followed by negative pulse or high to low, and binary 0 is represented by negative pulse followed by positive pulse or low to high, and it gives good timing information since there is a transition in the middle of a bit. So the Manchester code has a constant DC component and it is used in Ethernet local area networks. So here this is the data, given data 10110001. Let us see how ones and zeros are represented in Manchester. How 1 is represented, how do you represent 1 in Manchester? Binary 1, high to low or positive to negative. So positive to negative. Then binary 0, low to high, okay, or negative to positive. Low to high or negative to positive. Again 1, positive to negative. Then again 1, positive pulse is followed by negative pulse. Then 0, negative pulse followed by positive pulse. Then 0, negative pulse followed by positive pulse. Then 0, negative followed by positive. Then 1, positive followed by negative. So like this the data is represented in Manchester coding technique. Then biphase mark. The next type of encoding technique is biphase mark. So in biphase mark, so the important thing is, so there is a transition in the beginning of every bit interval. Okay. So signal transition occurs at the beginning of every bit period, and one how one is represented by additional transition in the middle of bit period. 0, no additional transition. So here binary code has a constant DC level. Similar to Manchester code, the frequency content is twice as much as for NRZ code. Then the biphase mark or space code has added advantages of being polarity independent. Let us take this example 10110001. How 1 is represented? 1 is represented by a additional transition in the middle. So there is a transition in the beginning, then there is additional in the middle of the bit. Then so 0. So there is a transition in the beginning of every bit period. So there is a transition. So it's high. So it's returning from high to low. Then there is no middle transition. So entire duration is represented by absence of pulse. Then 1. So there is a transition in the beginning. So it's going from low to high. Then again there is a transition in the middle. For 1 there is a additional transition in the middle. So it's moving from high to low. Then again there is a transition in the beginning of the bit. So it's moving from low to high. Again additional transition in the middle for binary 1. So there is a transition in the beginning, then no transition in the middle since it is 0. Then 0 again transition in the beginning, no transition in the middle. Then 0 transition in the beginning, no transition in the middle. 1 transition in the beginning, then transition in the middle. So like this the data is represented in biphase mark. Then the next one is pulse width modulation. In pulse width modulation, how binary ones and zeros are represented? Binary 1 has two timing durations, 0 has pulse width of one duration. So okay, let us take this example. How binary 1 is represented? Binary 1 is represented by a pulse of two timing duration. So two timing duration and 0 one time duration. Again binary 1, this 1 is represented by two timing duration, this one. Then again this 1 is represented by, what is the next data? 1 represented by two timing duration. Then this 0, this is represented by one time duration. Then again this 0, again one time duration. Then this 0, again one time duration. Then the last data is binary 1, which is represented by two time duration. So this is, so the data is represented in pulse width modulation. So here the signal level inverts with each bit. Here if you see signal level inverts with each bit, 0 to 1, then 1 to 0. So the timing information for synchronization will be good. So on the constant, our DC level, average DC level will be constant. Since the average pulse width varies with message content, the bit rate is not constant. So this code has inherent error detection capabilities. Baseband coding, this one example. So we are taking the same example to represent the data using various baseband coding technique, NRZ, Manchester, Wi-Fi and pulse width modulation. 1 0, the input data is 1 0 1 1 0 and 1. How NRZ waveform for NRZ, in NRZ baseband, how ones and zeros are represented? 1 is represented by a positive pulse, 0 no pulse, again 1 positive pulse, 0 no pulse, no pulse, no pulse, then positive pulse. Manchester. In Manchester, 1 is represented by a positive pulse followed by negative pulse, 0 no negative followed by positive pulse, then 1 positive followed by negative pulse, then 1 again positive followed by negative pulse, then again then 0 negative followed by positive, then 0 negative followed by positive pulse, then 0 negative pulse followed by positive pulse, then 1 positive pulse followed by negative pulse. Then biphase mark. So there is a transition in the beginning of each bit, and for binary 1 there is an additional transition in the middle. For binary 0 there is no middle transition. So 1 positive followed by negative, then 0, there is a transition in the beginning of the bit, okay, and no additional transition in the middle. Then 1, the beginning there is a transition, again in the middle also there is a transition for binary 1. Then 1, in the beginning there is a transition, then in the middle also there is a transition in the level. Then binary 0, the beginning there is a transition in the level, change in the level of data, then there is no change in the beginning, in the middle of the data. Then again in the beginning there is a change in level of the data, then in the middle there is no change in the level. Then 0, in the beginning there is a change in a transition in the beginning of the data and no transition in the middle. Then binary 1, there is a transition in the beginning as well there is a transition in the middle of the data. Then pulse width. Binary 1 occupies 2 duration pulse, binary 0 1 duration pulse. Binary 1 again 2 duration bits, 1, again 2 duration bits, then 0, 1 duration, then like that we have to represent the waveform. So this is how the binary ones and zeros are converted into electrical signal which can be transmitted through the medium. Then this is another example, 0 1 double 0 triple 1 0. How NR is how we are going to represent the given data using unipolar NRZ. What do you mean by unipolar? So it has only one polarity. Uni means what? A single polarity. So binary 1 is represented by a pulse and 0 no pulse or absence of pulse. 0 there is no pulse or absence of pulse. 1 there is a pulse. 1 is represented by a pulse. Again 0 no pulse, again 0 no pulse, then 1 is represented by pulse, 1 is represented by pulse, and 1 is represented by pulse, and 0 there is no pulse. Then the next type is NRZL, non-return to zero level. One binary 1 is represented by one voltage level and binary 0 is represented by another voltage level. So here let us take a binary 0 is let us assume that binary 0 is represented by positive pulse, then binary 1 represented by negative pulse. Then again 0 represented by positive pulse, 0 represented by positive pulse, 1 represented by negative pulse, 1 represented by negative pulse, 1 represented by negative pulse, then 0 represented by positive pulse. And then the next one is NRZI. What is NRZI? Non-return to zero inverted. In non-return to zero inverted, NRZI, it inverts binary 1. So which inverts the signal level at the beginning of the bit. 0, no change in the signal level. Again 1, there is a change in the signal level, then again change in 1, there is a change in the signal level, again 1, there is a change in the signal level, then 0, there is no change in the signal level. Then how to represent the same data using Manchester encoding? 0, how do you represent 0 in Manchester? Negative pulse followed by positive pulse, then 1 positive followed by negative pulse, then 0 negative pulse followed by positive pulse, then again 0 negative followed by positive pulse, then 1 positive pulse followed by negative pulse, then 1 positive followed by negative pulse, then again 1 positive pulse followed by negative pulse, then 0 negative pulse followed by positive pulse. Then the last one is RZ polar. So RZ polar means polar has two polarities. One is represented by positive pulse and 0 is represented by negative pulse. Non-return to 0 means each pulse returns to 0. How 0 is represented? Negative pulse, each pulse returns to 0. Then how 1 is represented by a positive pulse, it returns to 0. Then 0, that is negative pulse for returns to 0. Again 0, negative pulse, 0 is represented by negative pulse which returns to 0. Then 1 positive pulse. 1 is represented by positive pulse since it comes under NRZ which returns to 0. Again 1 positive returns to 0. Again 1 positive pulse, 1 is represented by a positive pulse, the pulse returns to 0. Then 0 negative pulse which returns to 0. So these are the various baseband coding techniques to represent the binary data. Modulation is the process of varying the uh, characteristics of carrier signal according to the instantaneous value of message signal. So here the carrier signal properties such as amplitude, frequency or phase is going to vary according to the amplitude of the message signal. So modulation is generally used to transmit data over a communication channel effectively. These are the various kind of modulation. So modulation is generally classified into two categories, analog modulation or and digital modulation. So in both kind of modulation, the carrier is always of analog type. In analog modulation, the message is of analog type, and in digital, the message is of digital data. So again, the analog modulation is classified into three categories: amplitude modulation, AM, FM, that is a frequency modulation, and phase modulation is nothing but PM. Again, the digital modulation is classified into four different categories: ASK, FSK, PSK, and QAM. So, in AM, the amplitude of the carrier signal is going to vary according to the instantaneous value of message signal. In FM, carrier frequency is going to vary according to the instantaneous value of the message signal. In PM, the carrier signal with the phase of the carrier signal is going to vary according to the instantaneous value of message signal. In amplitude shift keying, the carrier amplitude, this is nothing but the digital version of AM. So carrier amplitude is going to vary according to message signal. In FSK, the frequency of the carrier is going to vary according to the instantaneous value of message signal. In PSK, the carrier frequency is the carrier phase is varied according to instantaneous value of message signal. Whereas in QAM, both carrier and that is both amplitude and phase of the carrier is going to vary. Let us see each kind of modulation in detail with waveform so that you can easily understand. This is analog modulation. So analog modulation means the carrier is analog. Message is also always the carrier is analog in both analog and digital. Message is of analog signal in analog modulation. So this is called message signal. This is amplitude modulation. The first signal is message signal or low frequency signal or baseband signal. The second one is carrier signal or high frequency, and the last one is the modulator signal. See, this is the amplitude modulator signal and this is frequency modulator signal. Why this is called a low frequency signal? See this time period for one cycle. This is the time period. Okay, so here for one cycle this is the time period. So this is high, the time period is high means low frequency. Here this is the time period is low means high frequency. So time period high means it's a very low frequency. Time period high low means it's a high frequency. So the according to the concept of analog amplitude modulation, the amplitude of the carrier signal is going to vary according to the instantaneous value of message signal. As the amplitude of message signal increases, the carrier amplitude will be increased. So here from here to here it's increasing. So here to here it's decreasing, increasing. Then amplitude is decreasing. The carrier amplitude is also decreasing. Then the amplitude of message signal increasing, then the carrier increase, then decreases. So this is how the message will be transmit. The amplitude modulation signal will be obtained. Now let us see how the FM signal or frequency modulator signal is obtained. This is the message signal and this is carrier signal. What is the FM? The frequency of the carrier varies according to the instantaneous value of message signal. As the amplitude increases, the frequency will be increased. Okay, from here to here the frequency is increased. Then from here to here the frequency is decreasing. It starts decreasing. Then it starts increasing. So that here when the amplitude increases, we'll be getting the higher frequency. So the time period will be lesser. Then as the amplitude decreases, frequency will be decreased, then the time period will be higher. So again the frequency will be increased, time period will be reduced. And this is analog modulation or phase modulation, message carrier, and this is the modulator signal. So here uh, as the angle of the carrier signal varies. So this period here the we are getting the lagging. So here the carrier is compressed, so phase lead will be there. And the next one is digital modulation. And digital modulation, as we discussed, the messages of digital data and the carrier is always analog data. So digital data means ones and zeros. Carrier is analog continuous time signal. ASK amplitude shift keying. In amplitude shift keying, how one is represented by a pulse. Okay, so by pulse, carrier pulse. Zero, no pulse, absence of pulse. Again one, there is a pulse. Again 0, there is no pulse. On Here the data is on, here no data, here data on, data is present, here no data, on off keying. Okay, so hence it is also called as on off keying. In FSK, that is frequency shift keying. This is a digital version of FM. Binary 1 is represented by a high frequency signal, binary 0 is represented by low frequency signal. Binary 1 was, that is high frequency signal, binary 0 low frequency signal. Then PSK, that is phase shift keying. Here whenever there is a change in the data, input data, and you can see the phase shift. Okay, so as the data changes from 1 to 0, so there is a change in the phase. Okay, so the signal is getting inverted here. Again from 0 to 1 there is a change in the phase. Okay, so the signal is getting inverted. Right? There is a change in the phase. So this the data will be generated in PSK. I hope you will understand the kind of modulation and baseband, various baseband coding techniques.